The worksheet 3-6 is about estimating square roots. So before we start estimating these square roots, we want to first understand what rational numbers again are and what irrational numbers are. I hope you remember that a rational number is a number that can be written as a fraction. An irrational number, on the other hand, is any number that cannot be written as a fraction. So you may think that there's only a few numbers that cannot be written as a fraction, but there's infinitely many. And here are some examples. One example of an irrational number is the number pi. Pi is approximately 3.141592, and that decimal just keeps going on and on and on, and nothing's repeating. So in a way, you can think of this irrational number as any decimal that just goes on and on and on and on, but nothing ever repeats. This is what they call a non-terminating decimal. Alright, so any decimal number that never ends and never repeats is an irrational number. Another example is the square root of 2. The square root of 2 is approximately 1.4, and that decimal just keeps going on and nothing ever repeats. So that is what they call an irrational number. Another is the square root of 3. Alright? And that's what do you call that? Another one of those decimals that never end. I want you to try to at least figure out what you think that is. So if you think about it, we had a lesson ready on perfect squares. Alright? Perfect squares. All the square roots of non-perfect squares are going to be irrational numbers. So let me say that one more time. All the square roots of non-perfect squares are going to be irrational numbers. The first part to 3-6 is finding the two consecutive integers the square root is in between. On Monday, we started the notes, or we ended off the notes by making a table of perfect squares. And I told you that it's going to come in handy making this table. Alright, and this is where it comes in handy the most. So if you remember, you have this table of all these perfect squares. Well, for the first part of 3-6, they're asking you to find the two consecutive integers, again, integers, remember that part, that the square root is in between. So, here's an example. If I ask you guys, what two consecutive integers is the square root of, let's say, 13 in between? Then you got to say, find out what two perfect squares it's in between. Well, 13 is in between perfect square 9 and the perfect square 16. So that means the square root of the square root of 13 is in between the square root of 9 and the square root of 16. So you got to say, hey, the square root of 13 must be in between 3 and 4. So the two consecutive integers the square root of 13 is in between, I'm just going to put it down here, the square root of 13 is between 3 and 4. And I really didn't go over consecutive because I'm just making the assumption that you guys know what consecutive is, but consecutive means one number right after the next. So 4 comes right after 3, so those two pair of numbers are consecutive. So let's try another one of those examples of finding the two consecutive integers that this square root is in between. And this time we're working with the square root of 300. So what two consecutive integers is the square root of 300 in between? So first we got to remember the table. Alright, so we got to take a look at our table where there's the perfect squares and the reason why. Alright, so I'm going to jump a few because I'm not going to write down the whole table. But if you remember that 225 is a perfect square because it's the square root of 225 is 15. Alright, there's 1. 256 is a perfect square because the square root of 256 is 16. Right, 289, the perfect square of that. It's a perfect 289 is a perfect square because it's square root of 289 is 17. And then there was 324. And 324 is a perfect square because the square root of 324 is 18. I'll stop right there. We are looking for what perfect square is 300 in between. So 300, again, is in between perfect square 289 and perfect square 324. So therefore, the square root of 300 is in between the square root of 289 and the square root of 324. The square root of 289 is 17. The square root of 324 is 18. 18 is consecutive. 7 and 18 are consecutive to each other. So therefore, 300 is in between the two integers 17 and 18. The second part to 3-6 is approximating square roots of irrational numbers, or excuse me, approximating irrational numbers. All right, the square roots of non-perfect squares. So, as an example, again, you're going to need the table for this, all right? But this time you're going to actually go a little further and make a number line, 2 in fact, to help you do this without a calculator. So if I ask you guys to find, let's say, approximate the square root of 55. Well, first of all, 55 is not a perfect square. All right. So if you try to find what two perfect squares this is in between, it's in between 49 and 64. So that means it's in between the square root of 49 and the square root of 64. All right. So again, just like the first part of 3-6, we know it's going to be in between 7 and 8. So that means that this number has to be approximately 7 point something. All right, 7 point something. They're asking you to go to the hundredths place, so right now I'll be satisfied with the tenths place, so 1 decimal place. But if you can, try to estimate to the hundredths place. So we know it's going to be 7 point something. All right. So the best way to look at this is to make two number lines. The first one that goes from 49 all the way to 64. So I'm going to have to erase some parts there, but 49, 50, 51, 52, 53, 54, 55. I'm going to make that a little longer because that's what we're looking for. 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. And that's where I'm going to stop right there, 64. So the next part is making another number line that's the same length of that. All right? So you know that the square root of 49 is 7, so that part's 7. The square root of 64 is 8. All right? And if you try to estimate right smack where the middle is, that part is 7.5. Right there. Then you know that this one's going to be about 7 point. Or let's just try to split it up. You probably won't be able to do this exactly, but say, hey, that's 7.5. 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, 7.9, and then there's 8. Okay, so now we are looking to try to find where 55 is. So that means the square root of 55 is about right there. All right? And if your number lines were drawn correctly, it's pretty close to 7.4. All right? But it's slightly further down. So I would say, hey, that's about 7.39 or even 38 if you want to go that far. And you can always check with a calculator. And I don't mind you guys checking with a calculator. All right? So using two number lines, one that goes from one perfect square to the next one, and then the other is from one consecutive integer to the other. All right, and trying to figure out where that irrational number falls on the second number line. So let's try another one. For this example, we are going to try to approximate this square root of 75. So again, 75 is not a perfect square, but it is in between 64 and 81, right? 75 is about right there. So that means it's in between the square root of 64, which is 8, and the square root of 81, which is 9. So it's in between somewhere right here. So that means the square root of 75 is let me use approximate. By the way, the squiggly equal sign means approximately 8 point something. Alright? So, again, make your two number lines from 64 all the way to 81. So I'm going to draw a number line. I'll just go all the way and then start going 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. Made that a little bit longer. 76, 77, 78, 79, 80, 81. So here's 81 right there. Okay? So that's where I'm going to stop. You can go ahead and erase this if you wanted to. Just erase that part right there. Alright, so go back to this. And then make another number line from here, 64, all the way to 81. But this time you're going to think of the square root of 64, which is 8. The square root of 81, which is 9. Right, and try to guesstimate where the middle is. So there's 8.5. And then split it up again. 8.1, 0.2, 0.3. Whoop, I'm a little bit off here. 0.4, 0.5. 0.6, 0.7, 0.8, 0.9, and then 10. So I kind of messed up right around there. But right now we're focusing on where 75 is at. Okay, so 75 is right there. So the square root of 75 is falling right about there. So again, you're going to have to guesstimate. Here's 0.5, so that's 0.6. Right? Here's 0.7, so it's in between 8.6 and 8.7. So that's about 8.65. And that's a pretty good guesstimation. So I'm going to go ahead and write that down. So my estimate for the square root of 75 is 8.65. Alright? And that would be your answer for this one. I'm going to stop right here. I know there's other parts on there, but you can still use your skills in approximating irrational numbers or square roots of non-perfect squares and help yourself figure out which one's greater than, less than, or even equal to.